Okay, hello everyone. With China McPhee's with part 5 of our project. And in the last video, we encountered a little problem with the switch. And I said I was going to go back and see what was wrong with it. And I think I've figured it out. So, what was happening was that even though the idea was for a switch, once thrown to cut out the solar, to cut out the source, and thereby we were able to control what was happening in the source in case there was fire or anything. But for some reason, it kept on staying on. The reason for this I discovered was that our switch was not just a switch that created an open circuit; it was more like a toggle switch, right? So in other words, you really had a switch that, when thrown to the other side, actually make connection to the other side, right? It make connection to the other terminal. So what happens? Because we have DC as well, there's equally the opportunity for a backfeed. So when I threw my switch, right, and it's supposed to, I presume it was supposed to be open circuit. It wasn't. It opened it on one end, but it closed it on the other, like a toggle switch would, which meant that initially we would have our inflow, my positive, which was connected to the switch, would be cut off. However, because I have an in and an out with my charge controller, the reverse would happen. So what will happen now that my in will now be my out, my out will now be my in, feeding the charge controller, and then it will return through the other part. And when you're dealing with direct current, there is no polarity like we talked about, so it doesn't have any sense of positive, negative, and polarity is just going. It will take any path it sees and return. So to correct that, I decided to just take my switching after at the charge controller level. In other words, when the switch is thrown, again, this is a toggle switch kind of setup. When the switch is thrown, it will break everything from the charge controller level. But there's always the back feed. So I introduce a diode here, which will keep the current from flowing in the opposite direction once you throw the switch, which it essentially closes it at the other end. So in other words, but this circuit would have worked in the same way if I just introduced a diode anywhere here. But the difference between this and this guy has more redundancy, right? It has more contingency for flow, right? So if I throw the switch here, right, I could, without a battery, this guy will now feed and return. In other words, it would have fed and then returned. But now, if I throw the switch, it will now feed and return. And then once I have the batteries connected, it will backfeed and return. So I had multiple ways this was going to keep my switch and my LED or my light switch connected, and it would not accomplish what I put it there for, which is to shut out the source power. This, however, I believe would, with a diode, once I throw the switch, even though it allows it to go in the other direction, it cannot backfeed. This guy is essentially off, and this guy will essentially not backfeed, and there is no other redundancy. There's no other contingency for the flow anymore. So this is what we'll go with in our final, more aesthetic design. All right. Bye.